Hello and welcome back. We are in a new section. This section is all about file input and output, writing and reading from files. We're going to concentrate on text files, but we'll talk about binary files a bit as well. In this lecture, I just want to provide an overview, tell you what a file is, and tell you how it's good use for storing persistent data. So up until this point, all the data that our program accesses is via memory. Right? We're familiar with this concept of variables, structures, whatever it is, arrays. All the data that your program uses is in memory. And the reason that it's stored in memory is because memory is really fast. And you can access it quickly to perform calculations. You're doing the fetch execute cycle, all that stuff. So the scope, but it also is limited because the scope and variety of our applications, if it only uses memory, it's going to be somewhat limited. We know that memory goes away when the program goes away. And so that can be very limiting. All serious business applications require more data than would fit into main memory. Main memory is also very small, right? Nowadays, you can get a lot of memory, 32 gigabytes, but in the past, and especially on embedded devices, you don't have as much RAM. And as a result, your applications are very limited because of space and size. You really only want to store variables and things like that in main memory. It also, because main memory goes away, when the program goes away, you can't have any data that is stored persistent across reboots. So it all depends on the ability to process data that is persistent and stored on an external device such as a hard disk drive, these big programs. So you want to have this ability to store on the hard drive. It's a little bit slower, but you can store a lot of data on there, and big programs need to store a lot of data. C provides many functions in the header file standard.io.h for writing to and reading from external devices. You don't have to write your own code to read and write the files. But you can see the advantage that applications offer that have the ability to store data for a longer amount of time. A lot of advantages. The external device you would use for storing and retrieving data is typically the hard drive, the disk drive. However, the header file functions that we're going to talk about, you can use on any external storage device. So you could use it on a USB drive. You could use it on any external device that stores data. Okay, an SSD drive, anything. With all the examples up until now, any data that the user enters is lost once the program ends. This is referred to as volatile memory. Whenever you hear that term volatile memory, it means that the memory is not persistent, or the data is not persistent. It goes away when the program ends or if the machine reboots. So if the user wants to run the program with the same data, he has to enter it again each time so that it gets restored. It's very inconvenient. It limits programming. And again, this is volatile memory. When you store stuff in files and you store it on the hard drive, this is permanent storage. It's still there even when you reboot the machine or when your program is not running. That's referred to as non-volatile memory because it stays around. A file can store non-volatile data and is usually stored on the disk, or nowadays a solid-state drive, an SSD. It's a named section of storage, and the standard IOH is a file containing the user information in order to be able to read and write to those files. But we're going to use this concept of writing and reading data from a file for permanent storage. And you're going to notice how your applications become much more useful, much more robust, much more scalable, because now we have the ability to store large amounts of data. And we also do not have to worry about the data going away whenever the program ends or the computer reboots. So it's going to be very, very advantageous to use files. A file inside of, on the Linux operating system or Windows operating system is stored a certain way, but as far as C goes, the programming language, it's just a sequence of bytes. And each byte can be read individually. This corresponds to the file structure in Unix, but it doesn't necessarily, it only makes a difference when you're reading text files in Windows because you may have extra characters that you have to worry about concerning size. But it's just a sequence of bytes. So if you have a text file and it has more bytes, you can still read those bytes, you just have to understand what those bytes are representing. So here's what a file looks like and how we're going to read it and write to it. Using the C programming language. It's just a series of bytes with different offsets. Okay. The beginning of the file would be byte 0, and then you can always find different positions in the file could be 4 bytes into it, could be 100 bytes into it. And then you have the end of file, and the end of file is usually marked with a special marker called EOF, for end of file. So a file has a beginning and an end and a current position. The current position is defined so many bytes from the beginning. The current position is where any file action will take place. You're going to write or you're going to read at that position. And we're going to also talk about some functions where you can move around to move the current position. Anywhere you want in a file, even at the end, if you want to read at the end or write to the end. There are two types of files. There are text files and binary files. A text file is data written as a sequence of characters, organized as lines. Each line ends with a new line. And the text data can vary from system to system depending on how characters are interpreted. So for example, on Windows in DOS, every line has a carriage return and a line feed, so a \R and a \N. And so when you read the data or write the data, you have to understand this because the format's a little different. But on Linux, you don't have a \R. And so you have to understand how the text data is written, even though it's organized by lines and it's a series of bytes. Binary data is written as a series of bytes exactly as they appear in memory. So examples of files that have binary data are files like image data or music encoding. Binary files are not readable if you were to try to bring them up in a text editor because they are just bytes. We're going to concentrate on text files in this section, but you can write any data you like to a file. You can write it as a series of bytes and how they appear in memory, or you can write it as text. But once the file has actually been written, it's just going to consist of a series of bytes, even if it's represented as text. You can view text files in an editor, which makes it more readable. You have to understand that the format of the file in order to read it. And this is what I mentioned with if you're running on DOS, Windows, or Linux, where Windows may have extra characters when it writes data. So a sequence of 12 bytes in a binary file could be 12 characters. It could be 12 8-bit signed integers or 12 8-bit unsigned integers. Binary files are especially tricky because they just store what's as they appear in memory. So in binary mode, each and every byte of the file is accessible. But in order to read something from a file, you have to understand what's in there as far as data and how it's stored. And it may depend on what system you're running on, and it's going to also depend whether it's text or binary. Streams. C programs are automatically open on 3 files on your behalf. A stream can represent a file, but a stream is a more generic term that can represent any kind of input. So it could represent the keyboard, it could represent the console, it could represent a file, it could represent a socket if you're used to networking. Streams are a more generic term. And there's 3 streams that are opened up automatically for you in the C programming language. One is the standard input, and this is the normal input device of your system. Usually by default it's the keyboard. We've been using the standard input when we do scanf, but you could actually use scanf to read from files if you change the input stream. Maybe you change the input stream to a file. Standard output, this usually displays on the screen, usually via the console. Standard error is also on the screen, but you usually have to redirect it in order to see it, using like the ampersand 3 or something like that. But these are the 3 outputs. I mentioned standard input is the file that is read by getchar and scanf. Standard output is used by putchar, putS, and printf. We've mainly been using printf. You can also redirect files on the system to be recognized as a standard input or output. This is redirection. This is an operating system concept where you can redirect data. Send the output to a file, for example, or send the input, get input from a file as opposed to standard output. This is where you can use the less than or greater than symbols. The purpose of the standard error output is to provide a logically distinct place to send error messages. So it's kind of separate. Even though it's displayed to the screen, to access it, you have to have a special command. A stream is an abstract representation of any external source or destination for data. This is why it's more generic than, say, a file. The keyboard, the command line on your display, files on a disk, those are all examples of how you work with streams. Streams are going to be much more important when you start studying C++. The C library provides functions for reading and writing to or from data streams. So you can use the same input-output functions for reading and writing any external device that is mapped to a stream. Right, so that's why I mentioned you can use scanf to read from the keyboard. You could also use scanf to read from files. It all depends on what the input or where the stream is pointing to. And so the functions are very, very useful and very, very flexible to do this. And so this is just a high-level overview of what a file is and why we would use it, how it is persistent data. It's non-volatile memory. It stays around. We're going to use it, and we're going to use the standard I/O header file to read and write to it when we need to store data for our program. And our programs end up being a lot more robust, a lot more usable, a lot more flexible. So in our next lecture, we'll talk about actually implementing this using the functions in the standard I/O header. Thank you.